Here's a quick example of how to calculate Taylor polynomials and Taylor series. So we're going to do this for the function e to the x plus e to the minus x over 2. The first thing we need to do is to find the derivatives of this function and the values of the derivatives at the point around which we're going to do the Taylor series. So we're going to take a to be equal to 0. So we need to find f and all its derivatives evaluated at 0. So let's just do it for the first 4 derivatives and see what happens. Clearly f of 0 is going to be 1 plus 1 over 2, so it's 1. The first derivative is e to the x minus e to the minus x over 2. When we evaluate that at 0, we get 0. 1 minus 1 over 2. When we do the second derivative, we're back again to what we started with, e to the x plus e to the minus x over 2. So when we evaluate that at 0, we get 1. And then clearly for the next 2 derivatives, this pattern just repeats. So in general, if we take the nth derivative of this function and evaluate it at 0, we're going to get 1 if n is even and 0 if n is odd. So now we're going to write down the 4th degree Taylor polynomial of f at 0. So the general formula for this is going to be f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 factorial times x squared, etc. up to and finishing at x to the 4th. So we just substitute in the values we calculated on the previous slide. So that's going to be 1 plus 0 times x plus 1 over 2 factorial x squared plus 0 over 3 factorial x cubed plus 1 over 4 factorial x to the 4th. So sorting all that out, it's just 1 plus x squared over 2 plus x to the 4th over 24. Now let's find the Taylor series for the function at 0. Well, this is what we also call the Maclaurin series. So this is the infinite polynomial that we get by repeating this process. In general, the Taylor series for a function at 0 is given by this formula, the same formula except it continues on to infinity. So we're doing the full sum from 0 to infinity. When we calculated the Taylor polynomial of the 4th degree, we truncated at x to the 4th. We stopped there. Now we're doing this full infinite sum, but it's still going to be the same thing. We're going to get a half over x squared. All the odd terms are going to have coefficient 0 because these derivatives are 0. All the even terms are going to have coefficient 1 over n factorial. So we're just going to get the sum of all the even powers of x divided by the corresponding factorial. And the easiest way to write that is that it's x to the 2k over 2k factorial as k varies from 0 up to infinity. So this is a classic example of how you calculate Taylor polynomials and Taylor series. In general, of course, it's going to be much harder because finding all these derivatives might be very difficult for an arbitrary function, and finding a pattern that tells you what the nth derivative is might be almost impossible. So don't worry if you can't do this easily for an arbitrary function. We're just concerned at this point that we understand the concept and what these formulas mean.